We're being asked to complete this perfect square trinomial by providing the last term and then provide the factored version. Let's take a second and talk about what perfect square trinomials are and how they're formed. So perfect square trinomials are trinomials that result from the squaring of a binomial. And again, they're called perfect square trinomials because we're squaring something to acquire them. And so let's look at some examples real fast. So x plus 6 squared, to evaluate that, what we need to do is multiply x plus 6 times x plus 6, which requires us to FOIL. And so if we were to FOIL this expression right here, we get x squared plus 6x plus 6x plus 36, which simplifies down to x squared plus 12x plus 36. So this trinomial right here is called a perfect square. And again, it's a perfect square because it resulted from the squaring of a binomial expression. When we do this, there's a common pattern, or there's a pattern that appears. If you look at what I was squaring, this as x plus 6, specifically this 6 part, when I look at the terms, the linear term and the constant term of the result, I get 12x. This 12 is just 2 times the 6. And this 36 part is 6 squared. And that will always be the case when I'm simplifying these perfect square trinomials. Let's look at a different example. Let's look at this x minus 7 squared. So I can spend the time writing this out as x minus 7 times x minus 7 and then FOILing. But if I see the above example, what I know is a quicker way of doing this. What I'm going to get are these two negative 7x's that I'm going to combine together to get to negative 14x. And the last term is just going to be negative 7 times negative 7, which is 49. I can simplify that then using that logic just to say I know this is going to multiply into x squared minus 14x plus 49. And again, if you got any questions about that, you could verify by actually doing the FOILing action. This 14x right here, negative 14x, comes from a very similar statement of these double 6x's. In the case for the negative 14, that comes from a negative 7x and a negative 7x. And again, this 49 comes from that 7 being squared. And so what this negative 14x is the negative 14 part is 2 times negative 7. And this 49 is negative 7 squared. The third example here I have is a little more complicated, but follows the same patterns. And I'm going to write this whole thing out. So I get 2x plus 3 squared. I'm following this 2x plus 3. And what I get is 4x squared plus 6x plus 6x plus 9, which will simplify to be 4x squared plus 12x plus 9. Now this example doesn't follow exactly the same pattern as the top two, and that was because I have this 2x here instead of just an x. That kind of muddles it a little bit. But you will notice this first term is that 2x squared to get 4x squared, and this last term is the 3 squared. This middle term, this 12x, comes from these two 6x's here that are a combination or a multiplication of this 2x times 3 twice. Big picture though is that each of these results, this x squared plus 12x plus 36 and this x squared minus 14x plus 49 and this version down here of 4x squared plus 12x plus 9, they're all called perfect square trinomials. They're perfect square trinomials because resulted from the multiplication of a squared binomial. So this process is generalized in these statements below. This can be a little bit complicated, but I think that last example at least illustrates what's going on here, that when you square something to this a plus b squared is much like this 2x plus 3 squared, what you end up with is this first thing squared, and then in the end you get the b squared, and this middle term is 2 times what you get when you multiply the a and the b together. Most importantly, the most simple version of this is an example of what we had in our first two examples. And again, highlighting when we squared these, what we got was this term, this 12x, that was 2 times that non-x number, and this 36 was its squared. That's for a positive 6. In this other example, I had negative x minus 7 squared. I got this negative 14, which is 2 times negative 7, and this 49, which is negative 7 squared. That thought can be generalized in this statement below. What this is saying again, just to put it right next to this example, that when I take x plus 6 and I square it, yeah, I can spend the time foiling that out and reducing it or simplifying it. But what I know that's going to become is x squared plus 2 times our b value, or this 6, so 2 times 6 is 12x, plus 36, which is that 6 squared. What we're being asked in our original problem, they're giving us this part, and they want us to find, or to add on, this part right here. How we do that is we take this linear term, or this 12, this linear coefficient, we divide it by 2, to find out what number got doubled to get to that 12. Then we square that number to find that extra term. Alright, let's now apply this logic to our original problem. To make this a perfect square trinomial, the term that we need to add on here is the number that we get when we take this linear coefficient, this 20, and divide it by 2, and then square that result. In this case, we would get 100. Then the question becomes in the second part, so this first answer is 100. What we're looking for is what the factored form of this is. So what gets squared to get this expression right here that we've created? Well, what that will become is x plus or minus whatever number we got when we divided that middle term by 2, which in this case is 10. If we were to multiply this out in the ways described it previously, we would get x squared plus 20x's plus 100. So this now in this box is a perfect square trinomial, and this x plus 10 squared is the factored form.